This is part 2 of the 1.4 mini-series, and this is our final part. And I went through the steps in part 1 of how to do. I left those up there for us. And this is just a couple more examples. Actually, these two examples, this one was probably the most commonly gotten right, and this one's probably the most commonly missed. And so this one right here, you do the same thing on both. Okay, you let delta be the middle term without its coefficient. Now, if you notice, this is a substitution type problem, because you got to verify that. This is -1, -2. -2 doubles -1, so it therefore has to be a substitution type problem. So we let delta be x to the -1, because that's the middle term without its coefficient, and delta squared would be x to the -2, because that's the first term without its coefficient. So then that becomes delta squared plus 3 delta minus 28 equals 0. And then, like I said a while ago, it factors. So most of the time it does factor. So it'll be delta plus 7 minus 4. Okay, 7 delta minus 4 delta is 3 delta. So it does factor quite easily. And so delta is -7 and delta equals 4. Now, if you're going to miss it, this is probably where you're going to miss it at. You have to replace delta back for x to the -1. And the reason people would miss this quite often on this one, if you did actually miss it, the people who do miss it, they don't know how to solve this particular thing. You just got to remember x to the -1 is 1 over x. And if you can remember that, everything else is pretty easily. So x to the -1 is 1 over x equals -7. And this one's 1 over x equals 4. So just remember, if you take the reciprocal of both sides, you've got the answer. So the reciprocal of 1 over x is x, and the reciprocal of -7 is -1 over 7. And that's the x for this one. And on this one, take the reciprocal of 1 over x, take the reciprocal of 4 is 1/4. Probably the easiest way to think about it. So -1/7 and +1/4 are solutions, unless they are extraneous. And remember, x to the -1 is really 1 over x. So really the only number that wouldn't work would be 0, because you cannot divide by 0. Remember, in part 1 I said really the only time you're going to get extraneous solutions is if you have fractions. Now this one actually has a fraction. But the good news is the only thing that won't work is 0, because that would make that fraction 0. That's not my answers though, so we're good to go, unless I made a calculation error. So, but this one is usually gotten right. I mean, you think about it, but if you get a snag, the snag happens about right in here, because people don't know what to do with the x to the -1. And that's a basic math 103 concept, not a 135 concept. So it's the negative exponent rule. So now this next one, people miss it because they don't recognize it as a substitution type problem. But if you notice, there's an x plus 1 there and x plus 1 there. So that's kind of a dead giveaway that it is a kind of a substitution problem. And if you have x plus 1, now the square root of x plus 1 is x plus 1 to the 1/2. And that's why people miss it right there, because they don't recognize that the square root of x plus 1 is actually x plus 1 to the 1/2. If you can get that, you will be able to identify that this is 1/2 and this exponent is 1. And indeed, 1 does double 1/2. 1 is twice 1/2. So it is a substitution type problem. So therefore, you let delta, remember, be the middle term, which is the square root of x plus 1. Okay, and then the delta squared is just your x plus 1. It's kind of like, squaring the delta is like squaring the square root, and it just cancels, leaving me with the x plus 1. And then it becomes, okay, delta squared plus delta, because I'm letting delta be the middle term and delta squared be the first term, and minus 2 equals 0. And this becomes delta plus 2 times delta minus 1 equals 0. So delta is -2 and delta equals 1. And then you plug your square root of x plus 1 back in for the delta. And the square root of x plus 1 in for this delta. Now this one's kind of a, if you try to find that answer, well, you would get the square root of x plus 1 squared, so you square both sides if you try to do this. So x plus 1 equals 4, and so x equals 3. Now, if you tried 3, it wouldn't work. And the reason it won't work is because of right here. The square root of x plus 1 cannot be negative 2, because you just take the square root of anything. Okay, just put 3 back in. 3 plus 1 is 4, and the square root of 4 is 2, not negative 2. So when I noticed that was a negative 2 right there, I knew I didn't even have to do anything else with that particular problem. So 3 would be identified as an extraneous solution. So if you don't recognize that you can't do this, then you'd try to solve it, and then you'd notice later that it would be extraneous. But like I said, I would never even I wouldn't go that far with it. Right here, I would have noticed that that number is a negative 2. Square root cannot be equal to a negative anything. So that one I would just discard right immediately. Just throw that one out. And this one, okay, you can take the square root of something and get 1. So if you square both sides, you get x plus 1 equals 1. And so x appears to be 0. And 0 plus 1, square root of that is 1. So 0 seems to be fine. And you might want to go check and see if it is up there as well. 0 plus 1 is 1. Okay, it's 1. And then 0 plus 1, the square root of that is 1. So you got 1, 1. And 1, 1 is 2. And then 2 minus this 2 does give you 0. So this 0 seems to be gold. It seems to be fine. 0 seems to work. So, so this is example 3 and 4. So all these are substitutions. They're all on a different level. Some of these problems are a little lower level, and some of them are a higher level. But at the end of the day, they are solved the same way, and it's these steps. So, so when you're doing these problems, so if you're looking at this little mini series, this is the things that you need to guide yourself through. And when you get good at it and you get comfortable with it, you're going to stop following the recipe. Okay. So this is just kind of a thing to help you if you get hung up and, okay, what do I do now? What do I do now? And but when you're on the lettering, you don't have to be like you don't have to pick the delta. Some people choose not to use delta, and it would be they'd pick a more standard letter like the Y. But that's why I said a while ago, you have to be careful with those. But some people would use other characters. They personalize these things, and when you personalize them, you're more apt to remember. I know a teacher here at Missouri State, besides myself, she does not use delta at all. She uses another symbol, and she uses smiley face. That's her personal, and some of her students uses the smiley face instead of the deltas. I just don't do that. I just use deltas. You can use any lettering that you like, but if you make it personal, it usually makes it easier to remember. And when it comes to test times, and you're more apt to remember it. So personalizing things is actually a good thing when it comes to math sometimes. So I hope this helps.